All right, the next part of the kinematics is where we're going to start talking about how fast an object moves. We already talked about these terms. We can either measure how fast an object moves by using what's called speed or talking about the velocity. Just like with distance displacement, one of these is a scalar term, the other one is a vector term. Speed is defined as the rate at which distance is covered. Because of the fact that speed is related to distance, we can already tell that this is a scalar, just like how distance is a scalar. On the flip side, velocity is defined as the rate of change in the displacement over time. So this one is a vector. A lot of times you might think of velocity as essentially being speed but with the direction, but that's not always the case, mainly because of the fact that sometimes, because the distance and displacement aren't always equal, that means the speed and velocity will not always be equal in their magnitude as well. A perfect example is moving around in a circle. Um, when you go in around in a circle and you complete one full circle, you've traveled a certain distance. If it's a racetrack or the running track, then you've traveled an eighth of a mile. So your distance would be one eighth of a mile, and the speed would be whatever that is divided by your time. However, completing one full lap on that track, your displacement is going to be zero, which means your velocity is zero. So it's important to keep in mind that velocity, while it's a lot of times objects are just going to be moving in a straight line, so you can think of it as speed with the direction. It's important to realize that they're not always the same, and it's actually important to keep that in mind that the speed is related to distance and velocity is related to displacement, as we'll talk about in a second. So just like with distance displacement, they're both actually also measured in the same units because again, they're talking about the same thing. They're both measurements of how fast you're traveling, just with slightly different information. So for speed and velocity, they're both measured in meters per second. It's important to note though is that sometimes you can actually answer this in alternate units. I didn't mention this with distance displacement, that the most common unit is meters. However, you can technically answer distance and displacement questions in centimeters or kilometers. However, what's really important is that you maintain consistency in the question. A perfect example here is if your distance is in kilometers and, well, yeah, kilometers, and your time is in seconds, you might want to have your speed being in kilometers per second, just to make your life easy. However, if the answer is supposed to be in meters per second and you're given a distance in kilometers, you need to make sure you convert that distance or displacement before you follow through with your calculations. So just make sure that the units are matching, that your distance unit, whatever the unit is in the speed, matches your distance unit, and same thing for the time. Now, going back to the velocity, because velocity is a vector, which means we need to know what does it mean when we have a positive or a negative velocity. This made sense with displacement. You could think of being on a number line. If your displacement is positive, that means you were moved in the positive direction. You went towards the right or you went up. And same thing with the negative. You went in the negative direction, left or down. Uh, Positive velocity means that you are traveling in that direction. So you're headed towards the positive direction if you have a positive velocity. So you could technically be have a negative displacement. You could be to the left of some point, but moving to the right. So you'd have a positive velocity. Same thing with the negative velocity. That just means you're moving in the negative direction. So you're moving to the left or you're moving down. Another way to think about it is that you're moving backwards. These are all a variety of different ways of mentioning how an object is moving. Now, one thing to also keep in mind is since velocity takes into account both speed and direction, it's important to note that when we say that the velocity is constant, that doesn't just mean that the speed is constant, that the object isn't changing the value of how fast it's going. It also means that the direction is constant. So if you are moving at a constant speed and you were originally moving at 5 meters per second to the right, that means throughout your entire motion, you have to maintain that 5 meters per second to the right the entire time. If you start changing directions, you are no longer moving with constant velocity. This is going to be important later on when we start mentioning other types of variables and other things. There are other different types of speeds and velocities that we need to kind of mention. There's something called instantaneous speed. This is basically referencing your speed at a very specific moment in time. Typically, uh, we're usually talking about initial or final speeds. This also works for velocities too. Should point that out. Perfect example: speedometers usually reference your real-time speed, your instantaneous speed when you're driving a car. Um, the other type of speed is your average speed. So the average speed basically looks at the average of all the instantaneous speeds over the entire motion. Now, that would be insane to do in most problems. So we have two other ways of finding your average speed. The first is by looking at your total distance over total time. So if you want to find your average speed, you do your total distance divided by the total time, again, making sure that the units match. Uh, the average speed is represented by a V with a bar above it. The bar actually always represents average. Just keep that in mind. And then the other thing you could do is you could do average speed is the initial speed plus your final speed divided by 2. Initial is represented as V naught. That's what this little 0 is representing. And then the final is just represented as V. So these are two different equations that we could use to calculate the average speed. Now, one thing I should also point out is this v technically can also represent velocity. So this equation can represent the average velocity. So what changes about this equation if this is being used to calculate average velocity? Well, instead of it being distance over time, average velocity would be displacement over time. So this is important to keep in mind is paying attention to whether they're looking for average speed or average velocity because that's going to change what gets plugged in for x. Same thing down here. Uh, it does matter whether this is supposed to be average speed or average velocity because if it's average speed, then we just plug speeds in here. But if it's average velocity, then the v naught and the v need to have their respective signs indicating their direction. Uh, that's pretty much it. This equation is a pretty straightforward one. I should also point out a few other things. One, it's extremely important that you be very, very careful with this equation. Uh, Neither of these equations appear on the AP reference table. This first one, though in a slightly different form, does appear on the Regents reference table. This does not appear on anything, mainly because this is a definition. This is just the definition of an average. If I asked you to take the average of two exams, what would you do? You would add them, divide by 2. That's the same thing here. You would add the two velocities and divide by 2. But one thing to keep in mind is that a lot of times people will often drop this bar above the V and they'll mistakenly think that this is a final speed or an initial speed. It's important to keep in mind is that this is an average. And in fact, it's the only equation that has average speed in it for the most part. So that means we have to combine it with this equation because oftentimes you're going to be told initial and final. These are the more common speeds and velocities that you're going to be given. You're not normally going to be given average. So what I usually tell people is that I don't want you using this equation unless the object is moving at a constant speed or they explicitly say the word average speed or average velocity. If you are very careful, though, you can use this in conjunction with this bottom equation, and that's fine. But you have to treat this equation with a lot of caution because the reason why I consider this a taboo equation is because more often than not, you're going to use it wrong. So be very careful with this equation. That's pretty much it for the speed and velocity. There is another thing that I need to talk about when it comes to velocity, and I'll talk about that in the next video. If you have any questions, feel free to let me know. Otherwise, good luck and have a great day.